Okay, here we go. Complex fractions. Which of these two problems would you cross multiply?
Equals.
The one that says equals. Those are the kind you cross multiply. You do not cross multiply on multiply fractions. You multiply like this. 3 times 1 is 3. 4 times 2 is 8. 3/8. Get the idea? This one you'd cross multiply. 4x equals 3 times 12, 36. Divide both sides by 4. What's the answer? X equals 9. Okay. So just be careful. You can't just go cross multiplying everything that has two fractions in it. If it has two fractions with an equals, that's when you cross multiply. All right. I'd like you to try both of these and give me the right answers for them on your paper. Engage different part of brain. Yes? Want to borrow one from me? Okay. I want it back. Catch. All right. It always bothers me a little bit when people grab their calculator to do this, just because I want to make sure you, being some of the best and brightest kids in the room, are in the school. You're as bright as yourself. Way to go. No, because some of the brightest kids in the school feel like they can't do this in their head, but you can. You break it into, instead of 14 times 3, you break it into 10 times 3, and then 4 times 3. Hopefully you're cross-multiplying on this, aren't you? Okay, so you should be doing 14 times 3 to end at some point. And I'm sad if you grab your calculator for that. 10 times the 3 is 30. 4 times the 3 is 12. And then you add them together and it makes 42. Get it? If you didn't know that, it's a great way to multiply. Do the 3 times the 10 makes 30. 3 times the 4 makes 12. 30 and the 12 makes 42. All right, so you should have said 42 equals 2x. Divide by 2 on both sides. Half of 42 would be 21. Raise your hand if you had 21 on that one. Good. On to the next one. 3 and 12 have something in common. I could write this as a 3 times 4, and then I can cancel the 3's. The 4 and the 8. The 8 has something in common with the 4. It's 4 times 2, and then I can cancel the 4's. What's left when I'm canceling is a 1, so these are all 1s, which kind of just looks messy, but final answer is sometimes makes a difference. 2 over 4, which reduces to 1/2. Raise your hand if you had that one right. Okay, let me show you an example where when you cancel, if you cancel something, that you better make sure that you replace it with something. Okay, watch. I go cancel, 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 and the answer is 0. All right. Because that's a 1, that's a 1, and that's a 1. And that would be 1 plus 1 over 1, which would be 2 over 1, which would be 2. And if I start with the green numbers, so 5 plus 5 makes 10. 10 over 5 is 2. But I'm just showing you that if you cancel things and you try to just think they disappear, or even that they just, everything turns into a 1, so the answer is 1. No. Everything turns into a 1, so then you got to do the problem, and the answer in this case will be 2. All right, so when you cancel, you're making things into 1s. All right. Now, if I don't think we need to do another one of these. I think you guys get this. That's good enough. Let's talk about greater than or less than. Which of these two is greater than the other? All right. Is it related to cross multiplication in any way? Well, if I cross multiply, if you guys think 3/7 is bigger than 4/11, is that what you're telling me? Okay. If we make the denominators the same, and then it'd be really easy to tell, I agree. But is there some way we could tell with cross multiplying? Well, how about we cross multiply and see what we get? What's that? What's that? Well, first of all, we can see that they're not equal to each other. Okay, we know that fractions aren't equal, otherwise that should have come out equal. Now, if this one's really bigger, can you think of like a rule that we could use that would tell me which of these two, like when you cross multiply it, like All right. So there isn't any rule for cross multiplying that you guys know of. All right. Then all I'm gonna then make sure that you know is that if you cross multiply them, that if they were equal to each other, then when you cross multiply, they would be equal. All I can tell for sure is they are not equal from the cross multiplying. But if I wanted to tell that they're bigger, I'd probably use that same way that somebody mentioned already. Use the common denominator of 77. So if I make this into 77, so I'm going to have to times it by 7. If I'm going to make this into 77, I have to times it by 11. Okay, so then what would I end up having? 77 on the bottom. And then on the top here, 7 times 4 is 28. Over here, 3 times 11 is 33. Now, just a second. Interesting. So moral of the story is, well, now I can compare them, and I can tell that 28 compared to 33 that this one's bigger, right? So is there anything, so what can you say about cross multiplying and finding a common denominator? Once you cross multiply, you'll have 28 and 33, and then the denominator is this times this. So the top number here, we kept our answer over next to that top number. You get that? And the top number here, we kept our answer next to that number. All right. So by cross multiplying, we have a pretty good way of finding common denominators, don't we? And once we get the common denominator, we can tell pretty easy. Uh-oh. Beeping noise. The ending's pretty annoying. Okay. So let's try another one with the old cross multiplying thing. I'd like you to see if you catch on to what I'm talking about with cross multiplying. Oh, come on, iPhone, be quiet. I agree 10/11 is bigger, obviously, but I want you to just do the quick cross multiply thing and see if you can tell what they are with the common denominator, but use cross multiplying to get there. So where do I put this 70? On the right side or the left side? 70, and then remember the denominator is going to be what? 77s. And then where do I put this 5 times 11? Well, there's only one spot left, so 55 over. So now it's pretty easy to tell that one's bigger, right? Get the idea? You guys, so many little tricks you can use in math. Yes. The black things, they are pictures, yes. But I'm not doing those because I find them too distracting. Moving on. Here we go. Just tell me in your head, what do you think? Do you think that one's bigger than the other? The one on the left is bigger, or the one on the right's bigger? And how are you checking that they're equal so fast? So the way I would think of it, yeah, I can chop off a 0 here and a 0 here, and all of a sudden, whoo, it's the same thing. Otherwise, could you have done this times this, and that times that, and then they would have been the same, and then what? That means they're equal. All right? Okay. Is this true? You're just assuming. No, you're guessing. Can't you just cancel these x's and the answer is 1? Oh. So is it true or not? All right. All right, because How about these? Can't these two just turn into a 1? And then I'll have 1 plus 1 makes 2? All right. So this comes down to can or can't you cancel? It's a section on the worksheet. It's called can or can't you cancel. Tell whether the fraction can be simplified or not. Can you simplify it? Yes. Can you cancel those x's? Yes, as long as you replace them with ones. So it would end up being a 1 plus 1 over 1, which means 2 over 1, which makes 2. All right. No. All right. Tell whether the fraction can be simplified or not. All right. And here's the way I want you to think of it. When they get to more complicated ones like this, girls, don't. When they get to more complicated ones like this, factor whatever you can out of the top. And once I see, oh, there's an h in both of them, I factor it out, and I see what I have left. What would be left if I factored an h out of this? H to the third, and then I factor an h out of that. Plus 2. Okay, all over h. Now, these h's can simply cancel. And the answer is h to the third plus 2. All right, so if you factor stuff out of the top, then you got it down to just two things being multiplied on the top. And I think you always knew this. If it was like 5 times n over 5, then the 5's can cancel, right? If you got two things being multiplied up here, then yeah, you can just go cancel, cancel. All right. You swing your legs around and look at the thank you and then thank you. All right, so let's say we had, don't want to explain anymore, that. All right, how about that? Yes, and when you did cancel, the 5 would not factor out, the n would factor out, and I'd have 5 plus 1 all over, and these would cancel. The answer is 6. Another way, in this case, it's really easy because I could do 5n plus n is 6n over n, which would be cancel, cancel, 6. Okay, some of you guys, seriously, stop. Too chatty. All right, this one. Can you cancel stuff? Well, first you have to try to factor. All right, so on the top you have an x minus 3. On the bottom, can you factor that? Yes, you can. Try it right now. This is algebra. You are in algebra 2. Algebra should come easy. Remember then, x and x makes x squared, right? What multiplies to negative 12 and adds to negative 1? Negative 4 and positive 3 would add to negative 1. So there it is. And now I have an x minus 3 on the top, and I'm going to put it in parentheses just so it looks just like the bottom. Can you see anything that's exactly the same on the top and the bottom? Nope. All right, so therefore you can't cancel it. Even though these are really close to being able to cancel each other, they can't. They have to be the exact same sign as each other to be able to cancel. All right. Your homework is a lot like that. And we have a fair amount of... Okay, there was a lot of requests to see pictures. I have one good picture I'll show you at the beginning that I thought was kind of cool. The tentacles of the giant Arctic jellyfish can reach 120 feet. The tentacles are 120 feet. Okay, so that's like, let's see, a basketball hoop is 10 feet. Okay, so 10 basketball hoops would be 100 feet. So the height of 10 basketball hoops, 12 basketball hoops, yes. And, of course, how could you live your life not knowing this? Starfish don't have brains.
You don't need a brain, you only need a nervous system.
All right. Some scientist in the room says you don't need a brain, you just need a nervous system. All right. No. Okay. Time's up.